Subject of today's tutorial is the formation of radicals by cleavage of labile CC bonds. That this is possible, we know from the famous experiment of Gomberg done in the year 1900. Gomberg's intention was to synthesize the hexaphenyl molecule with a strained central CC bond because of the steric repulsion of the 6 phenyl groups. And he started with triphenyl methyl chloride and hoped that with zinc chloride will be formed. That is indeed true, and this molecule. But first of all, these radicals are formed. And as I said, the steric repulsion here is so determining that this is not formed at all. It wants to dimerize, to be stabilized by dimerization, despite of the mesomerical stabilization of the radical through the phenyl rings. And well, we could think of two alternative dimerization instead of the formation of the initial target molecule, either this dimer or that dimer. And it is clear that this is the preferred one, of course, since only one 6-membered ring is de-aromatized. Here, 2 of the phenyl groups would have been de-aromatized. This doesn't occur. That is the dimer of the so-called Gomberg radical. And here is an equilibrium at room temperature. We have about 2% of these radicals present at room temperature in solution with benzene or toluene, for instance. So an interesting question is, what about the stabilization of this Gomberg dimer? A stabilization if the hydrogen migrates to this position, certainly with the re-aromatized phenylene ring. This is thermodynamically far more stable than that. However, it is a catalyst needed for this transformation. It is possible, for instance, with catalytic amounts of a strong base, potassium T-butoxide, as a catalyst. Then this Gomberg dimer is smoothly transformed to this stabilized system with a yield of better than 70%. Thanks for listening.